Ladies and gentlemen, very good day. In the context of the energy transition, let me introduce today Triton, which is a startup active in the offshore wind energy industry with a vision of disrupting the future of wind energy. So my name is Vincent Dewulf. I'm the CEO of Triton, more known as Seawind, but today we are going to be called Triton because we have, in the meantime, developed three businesses. One is the turbine called Seawind, the other one is project called Del Toro, and number three is the port activities, which I will depict, called Oristano Cap. So the three questions I'd like to address or cover today are: can we accelerate the energy transition? Number two, who wouldn't like to contribute? And there it's tricky because a lot of people would love to contribute, but they get negative messages from the media, and they are not wrong. I give a few examples, specifically in the wind industry. It's all in the media, so it's not an invention. Vestas and Siemens Gamesa are really suffering financially with their offshore business. Ørsted is also in the same case for other reasons or some similar. And then the price of offshore wind energy is still on the high side. Projects are still being cancelled. And last but not least, the supply chain of this industry is moving very fast toward China. So who would like to finance when the activities are taking place somewhere else? So the question is, what could make the difference in these several issues? Now, I'm going to illustrate, I'm going to talk about my own journey in this energy transition, and then I will specifically make a deep dive in the turbine or in the Triton journey. So I'm an educated person by the oil and gas, so 25 years learning a lot in Shell. Then in 2015, I made a double jump, leaving the large corporate world and also leaving the oil and gas to focus exclusively on renewable energy. The first task was to convert palm oil effluent into electricity. The second task for me was to be the chief operating officer for a very dynamic company called Aqua Power, who developed and built the largest solar plant in the world so far using the CSP technology, which stands for concentrate solar power. Then I made a pause because then I wonder, where do I go next, knowing that wind onshore has very slim margin, PV the same. So I always had the technology nearby in my business, in my career. So I decided to try to find a technology that was not yet mature. And one day I discovered a LinkedIn post from Martin Jakubowski, who is one of the founders of Seawind. And I joined them 7 years ago. Now I'm gonna drill in the Triton control roller coaster, between brackets, because you will see that sometimes it's controlled from the market, from the outside, and sometimes we control it ourselves. So the first business, called the Seawind, is dealing with the turbine. First, I'll give you the history, which is quite interesting. In 1973, there was the first oil crisis, and European and American took a very different approach to address this issue. European, they just decided in Denmark to mimic the turbine in the prairies and to lead step by step, growing step by step towards the turbine that everybody can see all over the planet, called the so-called standard three-blader. In America, very different. Jimmy Carter signed a check to the NASA and asked, you deliver a utility scale wind machine to make electricity. And the gentleman who got this mandate, it was a 330 million check, which is $1.5 billion in today's money. The gentleman is Glidoman. Glidoman is a helicopter engineer. He spent all his life designing and building helicopters, so blades, he knows something about it. The first thing he did was to simulate turbine with the software that he created. And he tested different number of blades for turbines, and the best number was number 2. Two-blader are more efficient and more economic. He built his first turbine in '82 in the US, and for at least 20 years, if not more, this turbine only had a record globally of number of kilowatt hours for one turbine. At that time in '82, you can check, Vestas was not even 0.1 megawatt. Now you could smile and ask me, what have you done since then? But this is part of the journey of Seawind. Then he built 2 additional prototypes, a 2 and a 3, one to test the upwind, the other one downwind. Result was upwind is far better, normal, because the tower doesn't break the wind. And then he went in the street because America decided, Glit, we like you, but oil and gas is low again, so we don't need your machine. So luckily, Glit Doman was spotted by Italy, and Italy said, hey, come and build your next prototype here. He joined with Ansaldo, and the chief engineer is Silvestro Caruso, who is our second founder. And together they built Gamma 60, which is a 1.5 megawatt turbine, which proved the technology that we are pursuing today. So in 1997, dismantled, and then Enel, which is the utility company of Italy, decided let's order 12 turbines. And unfortunately, the management of Ansaldo decided a couple of weeks later, let's drop this business. We are going to focus to defense. That makes more money. And then you had Silvestro and Glit Doman left alone in the street. 2 top-notch engineers, not really businessmen. And then they met, or Silvestro met Martin Jakubowski in 2006 or 7 by coincidence, queuing in an airport going to the same destination. And then Silvestro brought the technology and Martin brought the vision of going offshore where you have a lot of wind. And together they built the first floating turbine in the world in the Adriatic with UK funding, including Shell and BP were part of the funding financiers. And after that experience, it was a tension leg platform. They decided this is too expensive to install in the wind industry where there is less margin. So we need really to work for the cheapest solutions, the lowest cost possible, because renewable energy is very diluted. Then they went in 2015, create Seawind in the Netherlands with the objective of creating and building and designing a Seawind 6 megawatt turbine, which is where we are. It is fully designed. We have now identified 3 sites in Denmark, the Netherlands, and Italy. We need to decide which one, but we're working on it. And funding-wise, we need 30 million euro to fund this prototype and run it for a year. And those 30 million, we have enough, we believe, followers, 3 Dutch agencies and EIB. But we still miss a lead investor, which would bring, we believe, between 5 and 10 million to unlock the followers. So that's where we are now. A few words about the technology. The turbine, in our case, works very differently with the wind than the 3-blader. For wind direction, it is the same in both cases. We put the nose in the direction of the wind, all fine. But for the wind speed, actually, you need to know that if the turbine rotates too fast, you might start burning your generator. So at some point, when there is too much wind, you need to reduce the exposure of your system to the wind. Otherwise, you burn the generator. So what the 3-blader are doing, they do a pitching mechanism, which is an active system. So when there is a lot of wind, they go more flat, and when there is no or less wind, they give an angle. But then knowing that blades are at least 100 meters long offshore and getting even longer, this is a cause of failure. In the case of Seawind, we have no pitching. So we have to do something different. So what we do, we have, if you can see that my hand is the rotor in motion and with the nacelle behind, then when the wind is, let's say, normal, it's perpendicular to the rotor, which you should see a disc, let's say. And then when wind goes up, what we do, like a sail, we go out of the wind and we go back into the wind when the wind goes down. Now, this mechanism of yawing, so rotating, is almost impossible, very difficult to do when the connection between the shaft and the rotor is rigid, which is a gyroscopic system. So to illustrate the point, the 3-blader can rotate 2 degrees per second. In our case, we can rotate 10 degrees per second. Why can we rotate faster? Because we break the gyroscopic forces thanks a hinge, which is a connection between our shaft and the rotor. This is a passive system where the blades are basically squeezed between big rubber blocks, and then when we rotate, the blades take an oscillation of 2-3 degrees, which neutralize the gyroscopic forces. Another way to explain the benefit of this hinge is when wind comes from my left and blow into the rotor in full motion, the blades being now 200-meter rotor diameter and longer, there is always more wind on the top side than at the bottom. So when it is a rigid system like a pitching is trying to make the work, but it's almost impossible. So it's an approximation, meaning as it is rigid, the connection here between the shaft and the rotor, there are bending moments in the shaft. In our case, we just take 2 degrees oscillation and we neutralize the gyroscopic forces. And the third difference is that we rotate faster, and if we rotate faster, the gearbox can be built lighter. So this is on the turbine. The last important message is that offshore wind has a potential of 18 times the energy, the electric energy that is produced by the planet. So there's a huge potential out there. Now I'm going to switch to the other business activities of Sea Wind. The other one is we can, luckily in Italy, create concessions on our own. In most countries in Northern Europe, you need to buy and pay hundreds of millions, but in Italy you can create a concession yourself. And the idea is to sell those concessions to big players. And we are talking now to interested parties, but there is no contract in the short term to be signed there. Now, when there is no cash in the company, we cannot build the prototype, but the good news is that our founders, they continue designing. So now in the meantime, we have a full design of a floater in concrete, and not only the floater, but we have also the port. We are now in the process to acquire this port. Now let's summarize this project, which is 60 hectares big in Oristano. We have today secured the exclusivity to buy the port. We don't have yet the full ownership, but we are applying to a scheme called Invitalia. So the project is 320 million, and Invitalia would be willing to provide half that amount as a grant with 3 conditions. Number 1, we need access to the port, which we have. We need the support from the local municipalities and the port authorities of Sardinia, which we have because they support us since day 1 when we were looking for a port. And last but not least, we need a loan of 150-ish million from a big fund and to whom we are talking now, and they are also apparently keen. And we are now waiting for the decree which unlock, let's say, this funding. And once it is published, we will apply, and then Invitalia have 90 days to give the answer to say whether we have it or not. So the summer will be hot in Sea Wind, or even I would say in Triton. Now the question is to survive all those years. What makes the difference, and to be successful? I'm not going to go through the long list, but you recognize all those words. I'll stop with a few. Technology. Yes, you can have the best technology on earth, but if you don't have the followers or the interested parties to finance, you have nothing. The same for most of them. Mindset, I'm stopping there, because when you go from oil and gas to renewable, there is quite of a mindset change to be done, because in oil and gas you have high margin and low climate impact, while the renewable is a complete opposite. So you need passion to go in the renewable industry. You need, of course, all those team competence, clients. But if you ask me what makes really the difference in this long list, there is one which really stands out, and that is collaboration, internally with and externally. That's why we invite anybody who wants to join. Is more than welcome with whatever support he can provide, from technology, from network to funding, small or big. If you want to know more about Triton, you have my email, and thank you very much for your attention.